time to 100% here. So in this session we are going to see about CMOS voltage transfer characteristics. The last session we have seen what is MOS transistor, metal oxide semiconductor transistor. So here we are going to form a NOT gate by using CMOS, that is combination of PMOS and NMOS. So NMOS will be at the bottom and PMOS will be at the top. So PMOS will be called as PUN, pull up network, and NMOS is called as pull down network, PDN. So here the transfer characteristics is shown in the figure, that is PMOS and NMOS. You take 1, 2, 3 up to 5 between the input and the output. You can see if you take 1, the NMOS will be in linear, PMOS will be in saturation region. If you take 0, NMOS will be in linear, PMOS will be in off condition. That is, we are giving the input 0 for Vn. We are having a bubble in PMOS. So the output of PMOS will be 1 because we are giving the input 0. So output will be in 1 condition. Whereas in NMOS, we are giving 0. The output will be in 0. So the PMOS is connected to VDD and NMOS is connected to ground. So what is the voltage in VDD? That is plus 5 volt is given to PMOS. The PMOS is in closed circuit. So the output from the VDD is flow through PMOS and you are getting at the Vout. Whereas in NMOS it is in open. So no voltages will be dropped towards the ground. So whatever may be the input we are giving, that is obtain the output when PMOS is in on condition and NMOS is in off condition. Next case, if I give 1 as the input, what happened to PMOS? So PMOS will be in 0 condition because of the bubble and NMOS will be in 1 condition. So PMOS will be open, there won't be any voltage obtained at the output of the CMOS inverter because PMOS is open. So VDD cannot be able to flow through this open circuit. Though we are having NMOS closed, we are not able to get the output. So these are the conditions we can apply for a NOT gate. When the input is 0, you can get the bubbled output as 1. When input is 1, output will be 0. So this CMOS is work as an inverter. We call this as a CMOS inverter. So in off region, we can take gate to source voltage is less than threshold voltage. In linear, it can be 0 less than V less than drain to source and source to drain voltages. The threshold saturation 0 less than gate to source voltages. Next one is pull up and pull down network. CMOS network consists of a pull up and pull down network. So pull up network consists of set of PMOS transistors and pull down network consists of set of NMOS transistors. Pull up network and pull down network implementations are complementary to each other. PMOS and NMOS serial topology to parallel topology. So here the consistency given, you can see in upper terminal we are having PUN and lower terminal we are having PDN. So PUN is connected to VDD and PDN is connected to ground. So we are going to take at the output in between PUN and PDN. So PUN is pull up network, PDN is pull down network. Right. For a CMOS, how we are going to get the output for the PUN as well as PDN? So first we will see PUN. So we are having the two inputs A, one input A and output B. So A will be 0. What happens to pull up network? When A is 0, what happens to pull down network? So we have discussed already. So first we will take A equal to 0. So we are having a bubble in pull up network, that is PMOS. So output will be B will be 1. Why? Because of the bubble. So what is the current flows in VDD that comes to the output B? When A is 1, the circuit will be open in PMOS because due to the bubble the output will be 0. So B is 0. Similarly, if you come to pull down network, in pull down network, if A is 0, though the circuit is closed, it is connected to ground, the output will be not able to get. So what is the previous voltage is maintained? That is maintained in the output voltage because PMOS is in open circuit. When input is 1, the output will be 0. Though there is no path present in PMOS, we are getting the output as 0. So combinedly we call this as, for A, if input A is 0, the output B will be 1. input A is 1, output B will be 0. So the combination of PUN PDN network forms a CMOS inverter. So this acts as an inverter. So in logical circuits we are using an inverter. Similarly in VLSI also we can able to obtain the same result by using CMOS inverters. So this is the gate symbol of a CMOS inverter. You can compare it with your logic circuits. So first one is the logic circuits. If you are giving the input as A, you are getting B, it is a bar circuit. 1 means 0, 0 means 1. Similarly, the same thing can be obtained by using this CMOS inverter we have seen previously. So this is PDN and PUN of a NAND gate. So NAND means not plus AND. So by using PMOS and NMOS, we can able to get a NAND gate. So PDN that is for pull down network will be in series and pull up network will be in parallel. So here we are taking two inputs A and B, which is connected in series in pull down and in parallel in pull up network. Always NMOS will be in series and PMOS will be in parallel. This is the logic in VLSI. That is NMOS will be in series and PMOS will be in parallel. Don't forget this. So with this we can able to draw an AND gate. So here we are taking two inputs A, B and C will be the output is common to both PDN and PUN. So we are having PDN below, that is NMOS, and above we are using PUN, that is PMOS. So consider the inputs of A and B. So different input, that is input is we are using for the PUN and PDN, that is in parallel PUN and PDN we are giving the input as in series. So first we will consider the series combination when A equal to A, B and the output is C. Pull down network we will consider first. So A, B. So NMOS will be in series and PMOS will be in parallel. So when the input of A is 0 and B is 0, what will be the output? Similarly, if the input of A is 0 and B is 1, what will be the output? Similarly, for the combination of 1, 0, what will be the output? For 1, 1, what will be the output? Similarly, for the pull-up network, how we are going to get the input as 0, 0, 0, 1, 1, 0 and 1, 1. What will be the output? You can see here, for combinedly pull down network, A is 0 and B is 0, the output will be open condition. Similarly for 1, 1, it will be in open condition because 2, 0, it will be in open condition because it is connected to the ground. When PMOS is in off condition, you cannot be able to get the output. So combinedly called as A, B, C, A and B are input and C is the output. If you combine for a CMOS inverter network, for 0, 0 you will get 1, 0, 1 it is 1 and 1, 0 it is 1. Similarly 1, 1, 0 it is 0. So this is a combination of an NAND gate. You can go for an NAND gate in logic not plus AND, you will get the output as 1, 1, 1, 0. Similarly we can obtain by using this circuit of an NAND gate in VLSI circuit. So this is a NAND symbol gate. You can compare it with the logic gate. The output, the truth table is shown in the above figure. Next one is for similarly for NOR gate, we can design a NOR gate. Just reverse the operation of a NAND gate, you will get a NOR gate. So here in NMOS we are going to connect parallel and in PMOS we are going to connect in series. The diagram is shown in the figure. So always I have told NMOS will be in series and PMOS will be in parallel for a NAND gate. The reverse operation is applied for NOR gate. So PMOS will be in series and NMOS will be in parallel. Don't forget this. PMOS will be in series and NMOS will be in parallel in NOR gate. Thus just reverse in NAND gate. Here also we are going to consider what will be the output if A and B are given as the input. What is the value of C for PDN as well as PUN? That is given in your truth table. So combinedly we can call A, B, C. A and B are the input. So A equal to 0 and B equal to 0, the output will be in one condition. So there is bubble, the output will be 1. There will be a connection in between both the input. For example, the VD is plus 5 volt. If I am giving the input of, first we will consider the upper terminal, that is PUN. It is connected in series. We are having a bubble because it is PMOS. If A equal to 0, B equal to 0 means the output of A will be 1 and B will be 1. So there is a path in between the output and the input. So whatever may be the VDD voltages, that is flow through C. For 0 0 you will get the CS1. You can see here. For 0 0 the output will be 1. Similarly for 0 1, so A is 0, the output will be 1. B is 0, the output will be 1. Here we are considering A as 0 and B as 1. So A 0 means that is output will be 1. B 0 means output will be 1. Reverse condition, you are getting the output as 0. Similarly for PUN, PDN network, the same condition, 0 0, you are not having any path because it is connected in the ground position. Before that PMOS will PUN is in open circuit, you are not getting as output, there won't be any path, so it is represented as Z. So combinedly we can compare this PUN, PDN combined together, which forms an NOR gate. A, B, C. A and B are input and C is the output. For the combination of 0 0 you are getting 1. For combination of 0 1 you are getting 0. For the combination of 1 0 0 you are getting 0. For 1 1 you are getting 0. So at last you have to realize that for NAND gate, NMOS will be in series, PMOS will be in parallel. Similarly for NOR gate, NMOS will be in parallel, PMOS will be in series. So with this we can able to draw any circuit with the help of NAND and NOR logic. So three important gates, one is NOR gate, then NAND and NOR gate. So CMOS inverter, then NAND logic and NOR logic is used for the design of the VLSI circuits. Thank you.